Hi dear students, welcome back to computer science class. In our previous session we have learned need for DBMS, components of DBMS and advantages of DBMS. In today's session we have another very important topic in DBMS or in database management system. It's all about DBMS models, or in short we can say data models. A thorough understanding of data models will definitely help you out in learning further. Means if you want to implement, if you want to know relational data model or SQL in detail, if you want to learn it, okay, you must have a clear understanding, you must have a thorough understanding of data models. So in today's session we'll be focusing mainly on data models. And actually what do you mean by data model? Any terminology can be defined simply knowing the term meaning of that word or the statement, right? Okay, so data model means just try to reverse the term. Data model data, it's incomplete, right? So model of data, right? So it gives us the logical way of representing or storing data in the database. That's what data model is. Simply we can say what the logical way of or the logical structure of data stored in the database. Okay, so that's what actually data model is. We can go further. Yeah, so actually data model means it defines how the logical structure of data is modeled. How the logical structure of data is modeled in the database. Of course, it gives us an integrated collection of what? Conceptual tools that defines or that describe the structure of database along with the data type, relationship and constraints. It gives us it's an integrated collection of conceptual tools. It's an integrated collection of tools that used to describe how the data is stored or the logical structure of data along with the associated data types, right? Associated data types of data stored in the database plus the relationships among tables or relations or the data, okay, plus the constraints. We know constraints are imposed in the data model or in the database just to ensure the validity of data, right? So just to make the data integrate or integrated data. Yes. Then it's a way to implement abstraction in DBMS. You know what abstraction is? It's a kind of idea, right? Yes. So data model is used to implement abstraction in DBMS, and it's a communication tool. It's a way to communicate how data is connected, how data is processed, and how data is stored. It's a communication tool that connects the different aspects of database, right? Different aspects like how data is stored and how data is processed and how data is structured or connected. Okay, how data is connected, how data is processed, and how data is stored. So these are the different statements using which we can define the term data models. Okay, so simply we can say what data model is a way. It gives us it defines how the logical structure of data is modeled, and it gives us what a connection or integrated collection. It's an integrated collection of different conceptual tools, various conceptual tools that describe how data is stored, what different aspects like data types associated with data models or data types, okay, data, okay, then relationships as well as the final constraints. Okay, yes. Then it's a way to implement abstraction DBMS. It's a communication tool. It connects different aspects of data like how it is connected, data are connected, how it is processed and how it is stored. And here we have four basic characteristics of data models. The first one is it should be presented graphically. Data models should be presented graphically. You know what graphical is? Using symbols and diagrams we represent things, okay? That's what graphical representation is. And the second point is data model should have no redundancy, okay? That is the initial stage. Defining or developing the data model is the initial stage of developing the database management system or the way we store and process data, right? That is the initial stage. So from the initial stage or at the initial stage itself, we have to start avoiding redundancy. Okay, so it should have no redundancy. Then it should be made available and shared by various applications. Okay, it should be made available and shared by different application programs or applications. Then data representation should be consistent, stable and valid. Data representation should be consistent, stable and valid, because as I've told you, data model, designing the data model, or what, developing the data model, that's the initial stage. So in the initial stage itself, we have to ensure so many things, like it should be consistent, it should be stable, it should be valid, then it should be made available and shared by all applications, and it should have no redundancy, and of course it's a data model, it's a pictorial representation, so it's represented using graphically, using diagrams and symbols. Okay, so these are the four basic characteristics of data models. And now we are going to look at types of data models. Okay, here we have a graphical representation of data models. So data models can be classified into three: object-based data model, record-based data model, and physical data model. Okay, object-based data model, then record-based data model, and physical data model. So yes, okay. You know what object-based data model is? Object-based data model is a data model that based on object-oriented concept in programming. Okay, it's based on OOP concept, object-oriented programming concept. Then record-based, it's based on record. It's based on what data. It's based on tables. Okay, mainly focusing on data. Okay, or record. Yeah. And finally, physical data model. It's connected to physical aspect, the actual memory storage or actual memory representation. Okay, the physical aspect of data model. But in our syllabus we have focused only on record based data model, okay, or data based data model. We can say what data based or record based, both the same. Okay, yes. So record based data model can be again classified into three, divided into three: hierarchical data model, it's a tree structure. Okay, then network data model, that is directed graph, represented using directed graph or digraph or simply graph. Then a relation data model using files, tables and or relations. Okay, using files, tables or relations. So data model can be mainly into three: object oriented data model, record based data model, and physical data model. Object based data model means it's based on object oriented programming concept. Record based means it's purely on data, and physical, the actual physical aspect of data storage. Okay, yes. Then record based into three: hierarchical, it follows tree structure, and network, it follows directed graph structure or graph structure, and finally relation data model, that is the one we have used and we are going to use. Okay, yes, which represent data in terms of files or represented like files, tables or relations. Okay, so this is all about types of data model. Now we are going to look at hierarchical, network and relational detail. Okay, so we can start with hierarchical data model. As I've told you, it follows tree structure. Okay, here is our first data model, hierarchical data model. When you look at hierarchical data model, the term comes to your mind must be tree-like structure, right? Means hierarchical data structure follows tree-like structure, like an upside down tree. Okay, yes. We can look at the points. Records are organized as trees. Here in hierarchical data model, when we follow hierarchical data model or in database management system, it uses tree structure for organizing records or organizing data. Okay, then it represents hierarchy of parent and child data segments, meaning in a tree structure follows on the top of the tree there will be a root, right? That's called parent. On the top of the tree there is a node, there is an entity that's called root of the tree or parent of the tree. Okay, and all others are children. Okay, or all others are child, or we can say root and nodes. Okay, sub nodes. Okay, yes. So it represents hierarchy of parent and child data segments. Then it looks like upside down tree. Okay, means root on the top. Yes, upside down tree means root on the top. Okay, yes. Then it depicts one-to-many relationship. You know what one-to-many relationship is? With this diagram we can explain this. Okay, you can see we have a number of records here. Here the first record is student. Okay, student is a parent record because this is on the top of the tree, so we can consider student as a parent. Okay, it's very simple how we take the parent. Parent is the node, or which is the record which is on the top of the list. Okay, that is what parent node is. Okay, here student is a parent node which is at the top of the node, top of the tree. Okay, then we have library, then exam, then fee. A library, exam and fee, all these records are child records. Okay, yes. So here in student, that's a parent table, not table, parent record. Okay, yes. Roll number, name and address are the fields. and in library, that's a child field. Roll number, ticket number and book issued are the what fields, and here in exam it's also a child. Okay, roll number, first term, second term and annual, and fee, that's the last type, child table, roll number, tuition fee, other fee and total fee. Okay, with this in this diagram you can see one thing. Here the parent table is student, which is located on the top of the tree. Okay, here is the tree. Okay, yes, then you can see the what data flow from student, it goes to what, library and exam, right? So these are the subnodes of student, which flows from what, student to library and exam, and from what, library and exam, then we have another node, another record, okay, another child, that is what fee is. Okay, so this is what actually one-to-many relationship is. Here one stands for the parent table, not sorry table, parent record. Okay, it's not table. Okay, yeah, it's record. Okay, so here student is the parent table, and that's what one is, one. Okay, parent is what one is, and M stands for many. Okay, many means child, children. Okay, yes. Here what's the value of M? Here it is 3, because we have 3 children, library, exam and fees. Okay, these are the children and student is the parent. So it depicts one to many relationship. One is the parent and many is the children or child. Okay, yes. Then we can see, let's look at the advantages and limitations. Advantages: the concept of hierarchical data model is simple. It is simple in operation and concept. Okay, the concept is simple as well as its operation is also simple, and it promotes data sharing. It promotes data sharing. Then because it's a database model, right? Yes. Then parent-child relationship ensures data integrity. Integrity means, of course, in every data model we can see the terminology integrity, right? We are establishing or we implementing the concept for ensuring the integrity of data. We cannot ignore the terminology, right? Okay. Then efficient and mapped for one-to-many relationship. Of course, it depicts one-to-many relationship. So these are the advantages. Okay. Simple in operation concept, promotes data sharing, then parent-child relationship ensures data integrity, then it's efficient and mapped for one-to-many relationship. Okay. Then limitations: it is flexible only for hierarchical data structure, right? Data model. It is inflexible for non-hierarchical. Okay, it is very suitable for hierarchical. Whenever we need a hierarchical flow of data. Okay. Yes, only at that time we can follow this hierarchical data model. That means it is inflexible for non-hierarchical. Okay, yes. Then second point, implementation is difficult. The concept is simple, but the implementation is difficult because we have to use pointers, and when we use pointers, we need extra memory. Okay, it takes extra memory, so it won't be what memory efficient. Okay. And the third limitation is dependency. Dependency means parent and child are connected, right? Child or children depends on the parent, or children or child derive from the parent, right? So dependency in the sense, when root node deletion happens, when we delete the root node, the entire child node will also be deleted. We will have to delete the entire child node. What happens? The entire structure will be deleted. That means children or child depends on the parent. So when we delete the parent, automatically children have to be deleted, right? So it deletes the entire structure, okay, entire model. Then the fourth point is change in structure. When we try to change the structure of the data model, what happens is change in all applications are required. Okay, when we change the data model, automatically we have to change. We have to make the changes in the applications. Which all applications the hierarchical data model is used. Okay, and here we have two examples, two data models which uses hierarchical data model. Okay, DBMS. Yeah, one is IBM's IMS. IMS stands for Information Management System. Okay, IBM's IMS Information Management System and System 2000 are examples for hierarchical data model. Okay, these two uses hierarchical data model. So this is all about hierarchical data model, and of course hierarchical data model here it's arranged like a tree structure, upside down tree. Okay, parent and children, okay, child. Okay, then one-to-many relationship. One stands for the parent and many children. Okay, child. Yeah, we have seen it. And example, what advantages: simple in operation concept, promote data sharing, parent-child data integrity, efficient mapping, efficient and map for one to many, and what some of the drawbacks. Okay, let's have a quick revision on data models. Data model means simply model of data. Okay, it defines how the logical structure of data is stored, how the logical structure of data is stored, and it also what collection of integrated collection of conceptual tools that describe which all elements, which all things that describe how data is stored, the attributes or what data types associated with them, relations as well as constraints. Okay, then it's a connector, it's a communication tool, of course. Then okay, then we have seen what how to make what are the rules or characteristics to be followed, or characteristics of what data models. Okay, we have 4 points. Yeah, after that we have seen a chart showing the division, the categorization of data models. Data model into three. What the first one is object oriented, right? Object oriented, record based, and physical. And object oriented means based on object oriented programming concept. Relational, what record based means based on data, purely on data, and the other one physical aspect. Okay, the actual memory. Yeah. Then record based into three, hierarchical, tree like. Then what network? It's a graph, directed graph. Then finally what relational database? It's based on files, tables, or relations. Okay. Then hierarchical data model, and we have two more data models: network and what relational. Right. That's what we are going to use in our +2 syllabus, as well as the most commonly used data model is of course relational data model. Okay, so this is all for the time being, and we can have those network and relational data model in our next class. Okay, so just go through all these topics. Okay, so thank you for watching. Have a nice time. Take care. See you in the next video.